Hello? Hello, anyone known about that? That is inversion of cane sugar into glucose and fructose by using mineral acid. So which mineral acid is used?
H2SO4.
H2SO4. Very good. Okay, so cane sugar, this is the homogeneous reaction or heterogeneous reaction? So that part we seen in what? Homogeneous catalysis. Okay. So today, the last two examples about what? Heterogeneous catalysis we want to see. Okay. Last time you also see manufacture of ammonia. By which process? Yes. Manufacture of ammonia by which process?
Haber's process.
Haber's process. Okay. And along with that, we've seen the different examples. So today, you see the screen? All of you see the screen? Yes?
Yes, sir.
Okay. Here, you see the one example which having vegetable oil. So all of you know that what is meant by vegetable oil, and that vegetable oil in liquid form. Okay. And that react with the hydrogen. Okay. In presence of catalyst what? Nickel. So it gives what? Vegetable ghee. So this vegetable oil is in liquid form. H2 gas is in the gaseous form. Nickel is in what? Solid form. And whatever product is formed, it is also in solid form. Okay. So this is the example of homogeneous or heterogeneous catalyst. Yes. Hello. This is the example of homogeneous or heterogeneous catalyst. कोणता असेल?
Homogeneous.
Hello. अरे समजतंय का? You have to give answer. Ketan Sutar.
Yes, sir.
Which type of this example? Heterogeneous or homogeneous?
Sir, homogeneous.
Which one?
Homogeneous catalyst.
So vegetable oil is in which form? Liquid or solid?
Liquid.
Hydrogen gas is in which form?
Gaseous.
Nickel is solid state. Okay. And your compound form, it is also in what? Solid state. So it is homogeneous or heterogeneous?
Homogeneous.
Which one? So here liquid. Huh?
Heterogeneous.
Here liquid. Here is what? H2O is in the gas. Okay. Here this nickel is in solid. And whatever vegetable ghee, all of you know that vegetable ghee is in the form of solid. Okay. So this vegetable oil liquid, as hydrogen gas form. This catalyst is in a solid, and your product is what? Solid. So it is the example of homogeneous catalyst or heterogeneous. Yes, Mayur Jagtap.
Heterogeneous catalysis.
Heterogeneous catalysis.
Heterogeneous.
Okay. So all of you understand it. Your catalyst and reactor are in different state. If it is in different state, then it is called as a heterogeneous catalyst. If it is in the same case, so whatever we see the example, I think we see the number of examples, that is oxidation of carbon monoxide to carbon dioxide in presence of nitric acid. Then hydrolysis of urea by urease. Hydrolysis of ester in presence of dilute HCl. Inversion of cane sugar. So these are all what? Examples of what? homogeneous catalyst. But in last lecture, we have to see the manufacture ammonia by Haber process, oxidation of sulfur dioxide to sulfur trioxide using platinum as a catalyst. It is also heterogeneous catalyst. And today we want to see the example vegetable oil, which is in liquid phase, react with hydrogen gas. It is in a gaseous form in presence of catalyst nickel, which is in a solid state, and the product form is in the solid state. Then it is called as a heterogeneous catalysis, which called as heterogeneous catalysis. Next, another example, that is I can write here this CO. Just wait. I would like to remove this one because we cannot understand. Okay, so I'm right here. Decomposition of steam by carbon monoxide. By carbon monoxide in presence of ferric oxide. Okay, so you see here is what? Carbon monoxide, CO. The carbon monoxide, what's its form? Yes, solid, gas, liquid. What is the form of carbon monoxide?
Gas.
Gas form. Okay. Okay. What is the form of H2O?
Liquid.
Liquid.
Liquid, or it may be sometimes steam. Okay, that is vapor form. Fe2O3, which form? Solid.
Solid.
Hydrogen is in gaseous form, and CO2 also in gaseous form. Okay, so what that example? Decomposition of steam by carbon monoxide in presence of ferric oxide. So whatever this steam, that is H2O. Okay, H2O is in the form of what? Steam, and that's why we don't write here liquid, we just write steam, because in heading you see that there is a decomposition of steam by carbon monoxide in presence of what? Ferric oxide. Okay, so ferric oxide, what's its formula? Fe2O3. Okay, and this ferric oxide decompose the steam in presence of what? Carbon monoxide. Then what is the formation? There is a formation of hydrogen gas as well as carbon dioxide. There is a formation of what? Carbon dioxide as well as hydrogen gas. So the reactant molecule is in different state, while catalyst also is in different state, and that's why this is the example of what? Which catalyst? Yes, which catalyst? Homogeneous or heterogeneous?
Heterogeneous.
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 Okay, so all of you understand this one? Yes or no? Hello? Hello?
Yes, sir.
Okay, so in your paper 502, what we want to see? We want to see the introduction. In introduction, we've seen what is meant by catalysis, what is meant by catalyst. Okay, what type of the catalyst? That is homogeneous catalyst and heterogeneous catalyst. Okay, now the most important point related to your syllabus, the industrial application of inorganic complexes. So why we add this topic in TYBSc? Because the student should know what are the industrial applications related to inorganic chemistry, because number of student says that inorganic chemistry having no industrial application, but you should know that all of you studied the coordination chemistry in SY BSc, and in coordination chemistry you studied that how the complex are formed, what is the nature of bonding in between metal and ligand, how the complex form, and what's its application. Okay, so in this catalysis, today we will focus on these different catalysis, that is hydrogenation. This hydrogenation is carried out by Wilkinson catalyst, hydroformylation, Ziegler-Natta polymerization, and Monsanto acetic acid synthesis. These 4 points are most important related to your this unit. Okay, all of you understand it? Yes or no? Hello? Hello? So, first we would like to see what is meant by the hydrogenation. Okay? So, anybody know that what is meant by hydrogenation?
Addition of hydrogen.
Okay, addition of hydrogen. So last time we see one mechanism. Okay, so here this is the olefinic. So all of you seen or not? All of you seen the PPT?
No.
Okay. Now you see. Yes, all of you seen this one?
Yes, sir.
Okay. So here you see that here is the carbon-carbon double bond. Okay. And in the third step, there is the addition of hydrogen takes place. Okay. So this phenomenon is called as a hydrogenation. Addition of hydrogen to the corresponding chemical compound is called as a hydrogenation. Okay. All of you understand? So, hydrogenation is a chemical reaction between molecular hydrogen, that is AS2, and other compound or element, usually in the presence of catalyst. Okay, so here most important statement regarding the hydrogenation reaction is what? There is a addition of molecular hydrogen. Okay, a chemical reaction between molecular hydrogen and other compound or element. Okay, so whatever that compound, it may be the olefin, it may be the different compounds. Okay, in presence of what? Catalyst. This is most important. So anybody asks you what is meant by hydrogenation, so you don't say like that addition of hydrogen. So you say like that hydrogenation is a chemical reaction between what? Molecular hydrogen and other compound or element, usually in the presence of catalyst. And what type of such catalyst is used for the hydrogenation? For example, nickel, palladium, or platinum. Okay, all of you understand what is meant by hydrogenation? So I think Dipali Singade. Dipali Singade.
Yes, sir.
So you understand hydrogenation?
Yes.
What is it?
It is a chemical reaction between the hydrogen molecules.
Okay, so you listen carefully. Hydrogenation is a chemical reaction between molecular hydrogen. So molecular hydrogen is called as a H2. Okay, it is called as a H2. So hydrogenation is a chemical reaction between molecular hydrogen and other compound or element, usually in presence of catalyst such as nickel, palladium, platinum. Okay, so this is called as what? Hydrogenation. All of you understand? Okay, so the process of hydrogenation is commonly employed to reduce or saturate organic compound. To reduce or saturate. Okay, means what? There is addition of hydrogen, and that's why compound becomes what? Saturate. Hydrogenation typically constitutes the addition of pair of hydrogen atoms to a molecule, often in alkenes. Okay, so in alkene, carbon-carbon double bond is there, and that's why two hydrogen, the pair of hydrogen atom is added in this. And catalysts are required for the reaction to be usable. Non-catalytic hydrogenation takes place only at very high temperature. So hydrogenation reduces double and triple bond in hydrocarbons. Okay. Means what? Suppose carbon-carbon double bond is there, ethene molecule, and you go for the hydrogenation. Your catalyst is what? It may be the nickel, it may be the palladium, it may be the, I think, platinum. Okay. So here, I would like to show you such a phenomenon. So everybody in the screen. So right now you see in the screen. Okay. Okay. So this is what? Ethylene molecule. Okay. And when the catalyst is what? कोणता कोणता कॅटलिस्ट आपण यूज करतो?
Nickel, platinum.
Nickel. Okay, let's see here. It may be nickel, then palladium, platinum. Okay, it is. So what happened here? If you use this catalyst, then so here is the double bond, okay, and CH2 double bond CH2, but by the catalytic activity, just wait. Okay, so ethylene molecule is there. Here is the carbon-carbon double bond, and when you apply for the nickel, palladium, or platinum, then what happen? One more hydrogen added in both sides. So alkene is converted into alkane. Okay, so double bond or triple bond that reduced by this catalyst. So that reaction is called as what? Hydrogenation. So hydrogenation is a chemical reaction between molecular hydrogen. Okay, so whatever molecular hydrogen present, that molecular hydrogen react with compound. So here is compound is what? Alkene. Okay, so that alkene compound reacts with the molecular hydrogen in presence of catalyst. Usually the catalyst presence is most important fact for the hydrogenation reaction, and such catalyst is nothing but the nickel, palladium, and platinum. Okay, and that nickel, palladium, and platinum reduces this compound with what? Molecular hydrogen, and there is an addition of hydrogen takes place. All of you understand this one? Yes? Yes or no? Hello. Hello. Everybody listen.
Yes, sir.
Okay, so all of you understand this. What is meant by hydrogenation?
Yes.
Okay. So that hydrogenation means what? Chemical reaction between molecular hydrogen with another compound or molecule, usually in presence of catalyst. Catalyst is what? Nickel, palladium, platinum. Okay. So another thing is what? So that reaction is carried out at very high temperature. So we want to see which catalyst. Wilkinson catalyst. And the Wilkinson catalyst for what? Hydrogenation. Okay. So all of you understand hydrogenation? Yes or no? Hello. Hello.
सर रिपीट करता का आवाज ब्रेक होत होता मधून.
Okay. Okay. So hydrogenation reaction is what? It is a chemical reaction between what? Molecular hydrogen. Okay. And that molecular hydrogen is reacted with what? Other compound or elements. Usually in presence of what? Catalyst. This is the most important sentence. Usually in presence of catalyst. And the catalyst is what? Nickel, then palladium or platinum. All of you understand?
Yes, sir.
Okay. So what happened? Carbon-carbon double bond is there. Carbon-carbon triple bond is there. If these two compounds, carbon-carbon double bond as well as carbon-carbon triple bond. So all of you know that if carbon-carbon double bond is there, then it is called as a alkene. And carbon-carbon triple bond, it is called as what? What called it? Hello. 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 If carbon-carbon triple bond is there, then what called it? Alkyne. Okay. So the carbon-carbon double bond or carbon-carbon triple bond, when you subject it to hydrogenation reaction, then what happen? Instead of CH2 double bond CH2, there is what? CH3 single bond CH3. So two hydrogen molecules add into that corresponding alkene molecule, and alkene is converted into what? Alkyne or alkane?
Alkane.
Alkane. Okay. If carbon-carbon triple bond is there and you carried out the hydrogenation reaction, then and then only there is a formation of what? Alkane. So it reduce the compound. Means what? Addition of hydrogen takes place. So this is called as a hydrogenation. All of you understand? Yes, no? Manoj Pawar, Ashish Pawar, all of you understand this one? Ashish Pawar?
Yes, sir.
Okay. So right now what we want to see? We want to see the Wilkinson catalyst. Okay. So we should know that for hydrogenation reaction, nickel, palladium, platinum or ruthenium, such type of metals are used. Okay. But in this catalysis topic, we mainly focus on industrial application of Wilkinson catalyst. And what is Wilkinson catalyst? You see, I would like to show you the structure of Wilkinson catalyst. And that structure, all of you seen this structure? Which metal is here? Which metal is here? What is the name of it? Hello? कोणता मेटल आहे? सगळ्यांना दिसतोय का?
क्लोरीन.
हा. RH. RH means what?
रोडियम.
रोडियम. ओके. तर विल्किन्सन कॅटलिस्ट जो आहे त्याचं स्ट्रक्चर काय आहे? रोडियम मेटल आहे. आणि हे काय आहे? हे वेज्ड लाईन आहे, ही डॉटेड लाईन आहे, ही स्ट्रेट लाईन आहे आणि ही लाईन आहे. त्या ग्रुपचं नाव काय? हे काय? अरे काय? फिनिल ग्रुप आहे ना? PH means what? Phenyl group. P means what? Phosphorus. How many triphenyl phosphine is there? 1, 2, 3. 1, 2, 3.
3.
Okay. So triphenyl phosphine. Okay. 3 triphenyl phosphine rhodium chloride. So this complex is here. So rhodium is the metal and triphenyl phosphine is the ligand. So all of you know that chlorine is ligand, this one ligand, this one ligand, this one ligand. Okay. So this shows that this is the below the plane, this is above the plane, and this is on the plane. Okay. So chlorine and triphenyl phosphine, that two ligands is on the plane, while one of the triphenyl phosphine is at below the plane and one of the triphenyl phosphine is above the plane, and that catalyst is called as a rhodium, that is Wilkinson catalyst. What called it? Yes, everybody? काय म्हणतो आपण याला? काय म्हणतो? मयुरी गुरु?
क्वेश्चन समजलं नाही.
कॅटलिस्टचं नाव काय? What is the name of catalyst? ओंकार जगताप.
विल्किन्सन कॅटलिस्ट.
विल्किन्सन कॅटलिस्ट. मग तुम्हाला एक्झामला हा असा क्वेश्चन असेल, which of the following element is present in Wilkinson catalyst, or which of the following metal is present in Wilkinson catalyst? ऑप्शन काय असतील? निकेल, पॅलेडियम, प्लॅटिनम आणि रुदिनियम. तुमचे आन्सर काय असणार? श्रेया हैरेकर. आन्सर तुमचा आन्सर असेल रुडियम. ओके. ऑल ऑफ यू अंडरस्टँड? सो what is mean by Wilkinson catalyst? So all of you seen the structure. Okay. So Wilkinson catalyst, its common name is what? All of you write down it. Chloro सगळ्यांना स्ट्रक्चर समजलं का? येस नो? अरे सगळ्यांना स्ट्रक्चर समजलं का रुदियमचं?
येस सर.
ओके. आपण इथं एक स्ट्रक्चर. ओके. सो chlorine is there. What is the ligand? Chlorine is the ligand. And another ligand, what's its name? काय त्याचं नाव आहे? अरे काय नाव आहे अनदर लिगँडचं?
ट्रायफिनल
TH3P. ओके. मग याचं नाव काय असेल? तुम्ही सगळ्यांनी कोऑर्डिनेशन केमिस्ट्री शिकलेला आहात. कोणाला नाव सांगता येईल का? ऋतुजा बागल. तर याचं नाव लिहून घ्या. क्लोरिडो. व्हॉट? क्लोरिडो. बिकॉज क्लोरीन इज देअर. ओके. क्लोरिडो ट्रिस. How many triphenyl phosphine? 3. That's why chlorido tris triphenyl phosphine. Which is the metal? Rhodium. Okay. And its oxidation state is 1. Okay. So what is the common name of Wilkinson catalyst? Is what? Chlorido tris triphenyl phosphine. Rhodium first. First is what? Oxidation state. It is in the bracket. Okay. So all of you write it. Pratiksha Kadam. Pratiksha Kadam.
Yes, sir.
हाँ. Common name सांगा Wilkinson catalyst चं. Hello, Pratiksha Kadam. Say the common name of Wilkinson catalyst.
सर आवाज ब्रेक होत होता त्याच्यामुळे काहीच कळलं नाही.
विल्किन्सन कॅटलिस्टचं स्ट्रक्चर बघितलं तुम्ही? प्रतीक्षा कदम.
हो बघितलं.
हा. मग त्यामध्ये कोणता मेटल आहे?
RH.
RH. रोडियम. ओके. त्याच्यानंतर आणखी लिगॅंड कोणता आहे?
क्लोरीन.
आणखी दुसरा? ट्रायफिनिल फॉस्फाईन. PPH3. ओके. तर त्याचं कॉमन नेम काय आहे? क्लोरिडो. कारण क्लोरीन आहे म्हणून. क्लोरिडो ट्रिस ट्रायफिनिल फॉस्फाईन रोडियम फर्स्ट. आता सांगा नाव.
क्लोरिडो ट्रायफिनिल फॉस्फाईन.
क्लोरिडो ट्रिस ट्रायफिनिल फॉस्फाईन रोडियम फर्स्ट. सांगा. प्रतीक्षा कदम. एक काम करू आपण इथं राईट करू. ठीक आहे. All of you seen the screen? Yes, no? Hello?
Yes,
सगळ्यांना
sir.
screen दिसते का?
हो दिसते.
ओके. तर आता आपण इथं काय करू? स्ट्रक्चर ड्रॉ करू. काय रोडियम आहे. ओके. आता इथं मला काय करायचं आहे? वन सेकंड. कोणता मेटल आहे?
रोडियम.
रोडियम. तर इथं 3 कोणते ग्रुप आहेत? PPH3. Just wait. The rhodium as the metal. Okay. लगे आता आपण करू. ओके, सगळ्यांना दिसतंय? All of you seen? Yes, no?
Yes, sir.
Yes, sir.
कोणता ग्रुप आहे? ओके, इथं सुद्धा कोणता असणार आहे? PPH3 म्हणजे कोणता? ट्रायफिनिल फॉस्फाईन. इथं कोणता असणार आहे? PPH3. ओके, आणि इथं कोणता असणार आहे? यस, क्लोरीन.
क्लोरीन.
एक पण फवारला असता काय बिघडला?
There is only Cl. Okay. Hello. Everybody seen this structure? Yes, no?
Yes, sir.
ओके, तर आता याचं नाव बघा. हा रोडियम ऍज द मेटल आहे. हा PPH3, याला काय म्हणायचं? ट्रायफिनिल फॉस्फाईन. ओके, तर याच्यामध्ये दोन टाईपचे लिगंड आहेत, क्लोरीन आणि ट्रायफिनिल फॉस्फाईन. तर याचं कॉमन नेम जे आहे ते आपण कसं लिहिणार आहे? क्लोरिडो. Okay, because chlorine is the ligand and alphabetically from this ligand chlorine is the first. Okay, then how many triphenyl phosphine group?
3.
So tris is there, chlorido tris, and in bracket triphenyl phosphine. Okay, all of you understand? Yes?
Yes. Yes.
So chlorido tris triphenyl phosphine, and what is the metal?
Rhodium.
Rhodium. Okay, and its oxidation state is a 1. Okay, so this is the common name of what? Wilkinson catalyst. What is that? Pratiksha Kadam,
Yes, sir.
what is the name? Read it.
Chloridotris rhodium.
First, rhodium. Once again, read it.
Rhodium first.
Okay, so this is the common name of what? Wilkinson catalyst. All of you understand? Yes, all of you understand this one? Okay. So this Wilkinson catalyst, we want to see with this its chemistry and how it is used for the hydrogenation. Okay. So first, we would like to see about the structure of Wilkinson catalyst, its common name, and its common name. All of you should know that its common name: chlorido, tris, triphenylphosphine, rhodium first. Okay, and we want to see the structure, its structure and basic properties. So generally, the rhodium is a transition metal. All of you know that. From the perspective of 18 electron rule, the 4 ligand each provides 2 electrons for total 16 electrons. Okay, so 18 electron rule, all of you know that, and each ligand, so triphenylphosphine and chlorine, also provides 2 electron each to the rhodium. Okay, so here is the 4 ligand, and that's why 8 electrons, so total 16 electrons are there. Such the compounds coordinatedly unsaturated. Okay, so this rhodium compound, that is Wilkinson catalyst, is saturated or unsaturated, but it is coordinatively, it is unsaturated. Okay, and it is susceptible to binding substrate like alkenes and H2. In contrast, iridium triphenylphosphine undergoes cyclometallation to give different compounds. So, like rhodium chloride, triphenylphosphine, there is iridium chlorophosphine is there. And another thing is that how to synthesize this catalyst. So Wilkinson catalyst is usually obtained by treating rhodium third chloride hydrate. Okay, so rhodium chloride hydrate, its formula rhodium Cl3 H2O thrice. Okay, and that I would like to show you, just to wait. So all of you see the screen? Yes, no? Hello? Hello?
Yes, sir.
Isti.
Yes, sir.
Okay. So you have to see rhodium chloride hydrate. This is the rhodium chloride hydrate. RHCl3H2O thrice. This is called as a rhodium chloride hydrate. Okay. So you have to see Wilkinson's catalyst is usually obtained by treating rhodium third chloride hydrate. So this is called as a rhodium third chloride hydrate with an excess of triphenylphosphine in with him. Okay, triphenylphosphine, you see here is the triphenylphosphine. Okay, and in presence of ethanol, you have to reflux it. Then triphenyl phosphine serves as two electron reducing agent that oxidize itself from oxidation state 3 to 4. In the synthesis, 3 equivalent of triphenyl phosphine becomes ligand in the product, while the fourth reduces rhodium third to rhodium first. Okay, so here you see that how many triphenyl phosphines are here? 4. 4 molecules are here, but in the compound only 3 triphenyl phosphine molecule are there. So one triphenyl phosphine molecule reduces rhodium third into rhodium first, along with HCl and H2 is the byproduct. Okay, all of you understand this? सर्वांना समजलं का हे? सर्वांना समजलं का?
Yes,
काय? ही रोडियम क्लोराइड हायड्रेट कशा बरोबर रिएक्ट होतो? ट्रायफिनिल फॉस्फाईन बरोबर. ट्रायफिनिल फॉस्फाईनचे किती मोलिक्युल्स आहेत? 4 मोलिक्युल्स आहेत. ओके, दिस 4 मोलिक्युल्स रिएक्ट विथ रोडियम क्लोराइड हायड्रेट. रोडियम क्लोराइड हायड्रेटचा फॉर्म्युला काय? RHCl3H2O thrice. Okay, and that react with 4 molecule of triphenyl phosphine. Then there is a formation of rhodium chloride trifluorophosphine along with one extra molecule of triphenyl phosphine is reduces rhodium third to rhodium first. Okay, and byproduct is what? HCl or H2O. All of you understand this one?
yes,
Okay, so this is the Wilkinson catalyst and how it is synthesized. In next lecture, we would like to see the another applications. So industrial application of Wilkinson catalyst in what? Hydrogenation. Okay, काय शंका आहेत का? हॅलो,
प्रोडक्ट फॉर्म कसं झाला ते परत सांगताय का?
काय ते?
प्रोडक्ट त्याचा त्या रिएक्शन मध्ये फॉर्म कसं झाला ते सांगा ना.
आताच्या का? रोडियमच्या का?
हा,
ओके, रिएक्शन एक मिनिट शेअर करतो मी. ओके, रिएक्शन दिसते? येस नो? हॅलो,
yes, sir.
त्याच्यामध्ये
हा दिसतोय.
RHCl3 याला काय म्हणायचं? रोडियम क्लोराइड, आणि तो H2O बरोबर आहे, त्यामुळे त्याला काय म्हणायचं? रोडियम क्लोराइड हायड्रेट. इथं दिसतं काय? रोडियम क्लोराइड हायड्रेट. आणि याची ऑक्सिडेशन स्टेट किती आहे? किती आहे? रोडियमची ऑक्सिडेशन स्टेट किती आहे?
1
आहे का? इथं विल्कन्सन कॅटलिस्ट इज युजली ऑब्टेन्ड बाय ट्रीटिंग रोडियम
3.
क्लोराइड हायड्रेट. इथं किती आहे रोडियमची ऑक्सिडेशन स्टेट? 3. ओके, ही कशाबरोबर आपण त्याला रिएक्ट केलेला आहे? विथ एक्सेस ऑफ ट्रायफिनिल फॉस्फाईन. म्हणजे आपल्याला किती मोलिक्युल लागणार आहे ट्रायफिनिल फॉस्फाईनचे? किती मोलिक्युल लागणार आहेत?
4 molecule.
4 molecule.
आपल्या कंपाऊंड मध्ये प्रोडक्ट मध्ये किती? हॅलो हॅलो,
yes, sir. Yes, sir.
प्रोडक्ट मध्ये किती मोलिक्युल आहेत ट्रायफिनिल फॉस्फाईनचे?
4 4
प्रोडक्ट मध्ये किती आहेत?
4.
प्रोडक्ट मध्ये, प्रोडक्ट हा प्रोडक्ट आहे ना इथं, हा दिसतोय का प्रोडक्ट?
हा.
किती मोलिक्युल आहेत हे?
3 6 ना.
किती?
3
आणि इथं किती आहेत?
4
हा, मग हे दोन रिएक्टंट आहेत. कोणते? रुडियम थर्ड क्लोराइड हायड्रेट याची ऑक्सिडेशन स्टेट किती आहे 3 आहे आणि एक्सेस ऑफ ट्रायफिनल फॉस्फाईन म्हणजे काय 4 मोलिक्युल्स आहेत ह्याला काय म्हणायचं एक्सेस. ओके हे एक्सेस काय आहे कारण की हा तुमचा प्रोडक्ट फॉर्म होणार आहे जेव्हा इथेनॉल बरोबर तुम्ही काय करणार आहे रिप्लेसिंग करणार आहे. हे क्वेश्चन मार्क दिसतोय ना तिथं काय माहित आहे का तिथं असा ॲरो आहे हे लक्षात घ्या. ठीक आहे समजलं का. अरे समजलं का.
येस सर. येस सर.
हा तुमचा कंपाऊंड इथे फॉर्म झाला कोणता विल्किन्सन कॅटलिस्ट. ओके याचं नाव काय क्लोरिडो ट्रिस ट्रायफिनल फॉस्फाईन रुडियम फर्स्ट. आता इथं रुडियमची ऑक्सिडेशन स्टेट आहे ती किती आहे 1 आहे आणि ही काय आहे बिकॉज इन द सिंथेसिस 3 equivalent of triphenyl phosphine become ligands in the product while the fourth molecule of what triphenyl phosphine reduces rudium 3 to rudium first. हा जो मोलिक्यूल आहे तो काय करतो इथं रुडियम 3 चं कन्वर्जन कशामध्ये करतो 1 मध्ये. ओके आणि ऑक्साइड ऑफ ट्रायफिनल फॉस्फाईन इज फॉर्म and that oxygen come from what this hydrated molecule. Okay plus 2HCl and twice H2O. समजलं सगळ्यांना रिएक्शन.
येस सर.
Yes, sir.
ओके तर ही रिएक्शन म्हणजे हे सिंथेसिस ऑफ विल्कन्सन कॅटलिस्ट तुम्हाला विचारतील एक्झाम तर तेव्हा ही रिएक्शन तुम्हाला तिथं लिहून हा जो काही एक एक्स्ट्रा मोलिक्युल आहे ट्रायफेनल फॉस्फाईन एक्सेस का घेतलं कारण की रुडियम थर्ड ऑक्सिडेशन स्टेटचं कन्वर्जन कशात केलं आपण रुडियम कशामध्ये केलं हॅलो कशामध्ये केलं आपण कन्वर्जन
रुडियम फर्स्ट मध्ये.
रुडियम फर्स्ट मध्ये. व्हेरी गुड. सगळ्यांना समजलं. समजलं का.
हो सर.
चव्हाणला समजलं का विकास चव्हाण.
येस सर समजले.
ओके आणखी काही डाऊट्स आहेत का.
No, sir.
No. I think 156 students joined the lecture. I think 300 students are there, but only 146 or 156 students joined the lecture. So this is not good sign of TYBSc students. Okay. तर काय शंका. हॅलो
Yes, sir.
काही शंका आहेत का. काही शंका आहेत का. Okay, so today we will stop here. Okay, next lecture we actually seen the applications of what Wilkinson catalyst. So you take care of yourself, stay at home, stay safe. Have a nice day. All of you leave the meeting. Next lecture I think your next lecture will not carry out. Okay.
Okay, sir.
येस सर.